All the definitions you need to know and more. Ready? Let us go. And let's do it off to the side. I guess over here. No, I guess I'll put it over here. You put it wherever you want. And right out of the book here, we have these definitions here. We have angles that are called adjacent angles. We did this last year? Yes.
Yeah.
And adjacent angles are angles, two angles that share a common side. Wow, where that came from. Why doesn't it go away? Two angles that share a common side. So if you look at our little example up here, okay, there are many, many, many adjacent angles. If you are looking for adjacent angles, angle 8 is adjacent to both angle 7. Why? Because they share, here's angle 8. It shares this side with angle 7. So angle 8 and angle 7 are adjacent. But angle 8 is also adjacent to angle 6 because they share a common side. Got that? Angle 3 would be adjacent to what? Kate, what other angle is angle 3 adjacent to?
Angle 4.
And angle
2.
No, angle 3 is
an angle
3 is adjacent to 1, it's also adjacent to 4. Okay, that's I got that one right. You with me on that?
Yeah.
Alright. Moving on then. We have what are called opposite angles. And opposite angles are angles that they are formed by intersecting lines. Formed by intersecting lines, and they do not share a side. By the way, they are also, these ones are also called vertical angles, aka vertical angles. And again, there are bazillions of opposite angles up here on this handy little thing up here. Angle 3, see these two intersecting lines? Angle 3 is vertical / opposite of angle 2. It is the angle that it does not share any sides with. Angle 3 and angle 2. Angle 4 is opposite of angle 1. Angle 8 is opposite of 5. I think you got the gist there. Then we have this. Now that we've done that, we have this little saying here. This is one I don't know if we've talked to you guys about it. Write this down in quotation marks. If we do this, two parallel lines. Does this ring a bell? No. Two parallel lines are cut by a transversal. Then I can tell you I don't remember much of my schooling when I was a youngster, but I definitely remember in geometry class the teacher making us say this and going over this. if two parallel lines are cut by a transversal. Which should make you ask this question. What is a transversal?
What is a transversal?
Wait, somebody didn't ask. Who didn't ask?
Aiden.
Aiden, did you ask?
Nope. Because he already did it.
I think we need to, hold on a second. So at this point, we gotta stop it, because using all my memory. There
Chrome
it is.
voice question.
It was again.
Chrome. Silly Google.
Okay, okay.
Well, you know, the thing with Google is, it like saves everything. So that when you go back to stuff, you can get back to it really fast, and then it makes copies of things, so if you exit out of something, it doesn't exit out of everything else. Okay, that should make this better, shouldn't it? Let's try that again. Trans, see how much better that is. Transversal is a line that intersects two other lines. And this, ladies and gentlemen, right here, this is my transversal. That is my, it intersects, what does it intersect? Not only does it intersect two lines, but in this case it intersects two parallel lines, and that's important. And that is important. It is, we'll get here. Oh, I missed, wait, I missed one other definition here. One more, another definition. Supplementary angles. Anybody know what supplementary angles are? Supplementary angles are two angles that put together form a straight line or equal 180 degrees. Supplementary angles are two angles that put together form a straight line or equal 180 degrees. Which means this, going back to my picture here, I'm running out of space to do this. Angle 6 is supplementary to what? Angle. What lines do you, when you put 6 with what other angle do you get a straight line? 8. 6 and 8 put together give you this straight line here. Or angle 6 is also supplementary to angle 5 because those two angles put together. Okay, and they know the beauty of that is if I knew that angle 8 was 100 degrees, then I know that angle 6 would have to be 80 degrees because they form a straight line. So there's supplementary angles. We got adjacent angles, opposite angles, supplementary angles. Now guess what? We have what's called corresponding angles. Running out of space here. I need a picture of, no. All right, ready? We did this, didn't we?
Yes.
Corresponding angles. Corresponding angles are the angles that if you could, well, I'm just going to say it like this. According to angles that match up with each other. They're angles that match up with each other when two parallel lines are cut by a transversal. Can you see that or even come close to that? Corresponding angles are angles that match up with each other when two parallel lines are cut by a transversal. I'll give you a chance to write that, and then we shall talk. Actually, through the miracle of this, maybe I can do this. Let me see if I can find this. Hold on a second. What are we at? What's my next subfolder? You people should know I do this enough. Where's it at? Oh, that wasn't right. What class is this? Course 3. What lesson is this? 50 what?
54.
54 angle relationships or transversal?
Angle relations.
I'm not sure which one it is. I'll probably guess the wrong one. There it is. Now take a look-see here at this. Oops. That's not what I wanted. My favorite tool is? Oh, it's already there. Gosh. That's alright, I'll do the one. Take a look-see at this. Let's go back, see if I can attach to this here. Paste. Now, do you think with that I can make that kind of see-through?
Yes.
Oh. So here is the deal. When we talk about corresponding angles, here's what you have to do. I used to say before, it is like this. If you could pick up this angle, this intersection, pull it off the paper and set it down on top of the other one, corresponding angles are the ones that fall on top of each other. But now that I can do this, I will show you. If I take this angle and put it on top of this angle, those are the angles that correspond. Angle 1 corresponds to angle 5 because it's right on top. It matches up with it. So angle 1 and angle 5. You know, angle 4 corresponds to angle 8. Got that? Does that make sense? Oh man, we don't even have enough time to do this. Okay, I'm going to get rid of this for just a minute. I'll get on this bad guy. I didn't want to do it. Put that over there. Okay, then we have what are called interior angles and exterior angles. If you have two parallel lines cut by a transversal, interior angles, they are the ones on the inside of the parallel lines. And I shall show you that with great fervor. If you look at the parallel lines, this is the interior part of the parallel lines. So what are my interior angles? Interior angles are angle 3, angle 4, angle 5, and angle 6. To which you are going to say, if there are interior angles, I'll bet there are exterior angles. You guys are really, really, really sharp as a bowling ball today. Yes. Exterior angles. They're the ones that are outside the parallel lines. And that, ladies and gentlemen, would be of such. I'll make this actually the same color here. This is exterior, as is this exterior. So what would be my exterior angles? 1, 2, 7, and 8. Now, you're ready for the actual math lesson part of today?
Yes, sir.
I need to fresh screen, but I'm going to put the same thing up there, because here is the basic gist. And gist is spelled how? Somebody, how do you spell gist? G, it's G-I-S-T. That's the way we spell gisty. Okay? Here is what we deal. This goes back to this. You have to say this first. If two parallel lines cut by transversal, then here are things that you need to know are true based on our definitions that we just gave there. The first thing, opposite angles are, ladies and gentlemen, equal. If angle 8 is 120 degrees, the angle opposite, which is angle 5, is also 120 degrees. It is just a thing. Okay? It is just a thing. If two parallel lines are cut by a transversal, then adjacent angles, angles that are right next to each other, are not equal, but they are, we've talked about this before, supplementary. They equal 180 degrees, which means if I know angle 8 is 120 degrees, I know the angle that's right next to it, the adjacent angle, has to form a straight line, which makes it supplementary, which makes this angle 60 degrees. Okay? I know that if two parallel lines are cut by a transversal, corresponding angles are, everybody want to speculate? Angle 8, which corresponds to angle 4, they are equal. They are equal. So angle 4 has to be 120 degrees. Boom, boom. Angle 7 has to be, or 3 has to be 60 degrees because it corresponds to angle 7. I know if two parallel lines are cut by a transversal, here's one that shocks most people's world. Alternate interior angles are equal. To which you may say, what? Alright, if you think about what the word alternate means, you know, if you alternate between two things, it means you kind of flip-flop. Well, we already talked about this as being interior. Alternate interior angles, okay. First of all, we only have 4 interior angles, 3, 4, 5, and 6. Alternate interior angles are the ones that fall on the from one side to the other of the transversal. In other words, angle 6 is an alternate interior angle with angle 3. They flip-flop sides of the transversal. Angle 6 and angle 3 are alternate interior angles, and they are equal, as are angle 5 and angle 4. Those are alternate interior angles. And not to confuse you even ever so much more, but if there's alternate interior angles, guess what? There are also alternate exterior angles, which is the next thing. Alternate exterior angles are also equal, which means if you had to speculate what angles would be alternate exterior angles, and it's the same thing that's true, we know that these are the exteriors. Alternate means it goes from one side to the other side of the transversal. So what? Name for me 2 sets of alternate exterior angles, Brendan Massey.
Angle 8 and angle 1.
Correct. Angle 8 and angle 1 are equal, as are angle 7 and angle 2. Those are all equal angles. See if I forget anything. Okay, because, let me give you the whole gist, spelled with a G. Here's what it looks like in the world of geometry. Okay, let's see if you can pick up on this. The thing with the world of geometry is that you have to do what they say, prove things based on what you know. So let's say I have those lines. Let me just label them as 1, 2, 3, 4, 5, 6, 7, and 8. If I tell you if angle 8 is 135 degrees, what are the rest of the angles? Okay, but you can't just tell me, you have to prove it. And that's what geometry is all about. You can't just say things because you think it is, you have to say things because you know it is based on what you've been told. So here's what that would look like. I know that angle 8 is 135 degrees. Because I know angle 8 is 135 degrees, what else do I know? What can I figure out and for what reason, Ephraim?
That angle 1 is the same.
Okay. Ephraim says that angle 1 is 135 degrees, but you can't just tell me why. Why? For what reason? Because it is
An alternate.
There you go. And you have to say that. You say it is 135 because it is an alternate exterior angle to angle 8. Very good. What else can I know that? So I know that angle 1 is 135 degrees. Somebody, give me another one. Sam, I know that angle 6 is 45 degrees because it is supplementary. And it's supplementary to angle 8. Now you're talking with. What else? Tell me the rest. Somebody give me another one. 8 and I know that.
Angle 7
is
135 degrees.
Angle 7 is not 135 degrees.
Oh, it's 45 degrees.
45 degrees. Now, there are multiple reasons you could tell me that. What is one of them? How do I know?
It's adjacent to angle 8.
Right, because it's adjacent, and adjacent angles have to be supplementary. What other reason, though, now that you have that? Why else is it also another reason you could give that it's angle 7 is 45 degrees is because, anybody? Brady?
I forgot the word. I'm looking.
Aiden?
It's opposite.
Right.
Of
Or it's because it is also because it's opposite angle 6, and opposite angles are also equal. Now, how about this? Angle 5, I'm going to tell you, is 135 degrees. Whoa. And you should be able to give me 3 different reasons why that is or could be 135 degrees. What would they be? It's 135 degrees. And the nice thing is about geometry is it lets you like really abbreviate it. I mean, when you write it down, you can just write blah, 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 blah. What's one reason this is 135 degrees? Because it is, Brady? Opposite of angle 8. Another reason it's 135 degrees is because it's actually you could actually give me 4 more reasons or 3 more reasons. 135 degrees because Brady?
It's adjacent
to
angle
6, and it's also adjacent to angle 7. That could be another reason. Another reason is, Ephraim?
They're opposite.
Did we say that already? Opposite angle 8? Yeah. Another reason, Danny?
It's supplementary to angle 7.
Right, we already got that one. I got all the supplementaries. So there's one big one you're missing yet. Brendan?
Corresponds with.
Exactly. It is a corresponding angle also to angle 1. Because if you rip this up, put it on top of that, angle 1 and angle 5 match up, therefore they are equal. And this, ladies and gentlemen, we shall continue our whatever conversation on that model. All in a